but it actually enabled an ecosystem where ISVs felt confident putting their software into Docker containers, into the Docker image format, because they knew that they wouldn't have to go back and redo a build for Red Hat, redo a build for Ubuntu, redo a build for Canonical, for Debian. And you saw repos on our public repo called Docker Hub explode to over 200,000 and 2 billion downloads in the last 18 months, all because of the portability. The third aspect of the democratization of containerization is the openness. And it's an open source conference, right? So I can't not say something about openness. No, but seriously, so obviously Docker is known as being open source. It obviously makes it readily available for developers and system admins to download and start to use. It obviously allows for massive community contributions. But the other aspect of openness, which is very important, and this began to be deliberate very quickly because we realized we couldn't build it all, was the Docker community constructed the platform with the interfaces that were facing the application implemented through plugins. And this was very deliberate because we knew that there were going to be different stacks for networking and different stacks for storage and different file systems. And we knew that a small team, and although the open source contribution surface area grew to over 1,000 contributors, even with that amount of resources, we weren't going to cover all the different aspects, all the different implementations. And so that led to a policy we called batteries included but swappable, where Docker will ship, the Docker project ships with an implementation of that API, of that networking interface or that storage interface or that file system. It ships with an implementation, so out of the box, the developer or sysadmin can get going and be successful and do a hello world, do a quick proof of concept. But it can be swapped out with a plugin produced by any number of the ecosystem partners. So if they want to swap in a plugin for a Cisco networking stack or swap in a plugin for EMC storage stack, they can do that. And that's led to a very active ecosystem, 450 partners at last count, who have built some sort of plugin to one of these many interfaces in the Docker platform. And so as a result of this, as a result of the accessibility, the portability, and the openness, it's allowed the project to take off. And this is a simple chart from Google Trends, but you can see from spring of 2013 to today, has just increased in interest and adoption across the world because of these three factors that have made it so much more accessible, so much more adoptable by folks outside tech, honestly, right? So where do we go from here? Reflecting on those and thinking about year 4 and beyond. Again, not premeditated by any stretch, but it pretty quickly became aware of us and most of the folks in this room that this wasn't just a change in a simple image format, but this was actually a change in how we're going to architect applications. And we've all been around for a while. These changes in the stack, they don't come through every year, right? They come through every 8 to 10 years when everything in the stack just kind of says, whoop, all right, we're gonna redo it. And you can see kind of the major shifts behind me here. And whether you call it microservices, whether you call it containerization, cloud native, whatever label you favor, this is the next 10 years, right? And we're just getting started. And we would say that we're, you know, if Basecamp and the kickoff for democratization was March 2013, we would say we're only at Camp 1 now, right? We've got a ways to go because these decade-long shifts take a long time for the users and the customers to get comfortable and to have the services and the full tooling that they need. It takes a while for all of us to mature the interfaces and create the technologies and the plugins and the ecosystems to make that all work for them. And so it's a lot of work. So what can we learn from the first 3 years of democratization that'll help us in the next 3 years? So I have some thoughts. I'll share them. Grab me afterwards and tell me I'm crazy, tell me to double down, somewhere in between. We have to continue to make it accessible for those not in this room. the first 3 years were good, right? I mean, enterprise IT is going nuts over Docker containers. Cloud Foundry's a great partner in helping them adopt it in their segment of the market. Lots of other partners in the room. I see Jason IBM in the back. Like there's lots of enterprise IT interest, but it's the early edge of the enterprise IT market. It's not the laggards, right? It's not, I won't name vendors who sell to those laggards, but there's a whole half of the market, at least 2/3 of the market, I would say, that isn't going to get there in our current state of the state. One of the initiatives that we're very excited to be proud of, we announced it this morning, is our CTO is going to be joining the Cloud Foundry board, Technical Oversight Board, and the Cloud Native Computing Foundation is going to be building reference stacks of known components that work together with a combination of technologies, all of which work on Docker. So there'll be a Kubernetes reference stack, there'll be a Docker Swarm, which is our cluster manager reference stack, there will be a Mesos reference stack, all working on Docker. And these will be known, configured, instrumented, different components that work together that you can take to an enterprise IT organization as a prescribed method for getting successful at this new computing model, at this new application model. Many of you know, enterprise IT, the laggards, they welcome prescription. They want us to tell them how to best use our technologies to be successful. And reference architectures, reference stacks are exactly what we need to do to help get that next wave of the market adopting our solutions. A second really exciting, I realize I'm in the Linux house, Jim, but a second one that is very, backwards. Sorry, I jumped on the screen. I know I'm in the Linux house, Jim, but Windows is coming. All right? Talk about opening up the next waves of accessibility markets. I mean, again, this is a fun stat. It says just the server side. This is not desktop, just server side. 3x, 4x, what the Linux server side is. And think about Visual Studio, .NET tooling. Think about all the developers that have been, honestly, decades educated by Microsoft and their tools, all accessible to this new application model. We were in front of a customer in the Midwest the other day, and they have 10,000 Visual Studio devs, and they asked me, look me in the eye, point blank, should I retrain them all on Java and Linux? I said, no. If you want to take advantage of microservices, this new cloud-native computing model, it's coming. It's coming with Microsoft. Great partnership with Microsoft, but many folks here in the room, Kubernetes, Apprenda guys, IBM's been pitching in. It's been a wonderful community effort to open up this next wave to the Windows community. Portability 2.0, what does that mean? The promise of portable in 1.0 in the first 3 years was the individual container. It was the developer or sysadmin could create that container. Its only dependency was a Linux kernel, so it could go from Red Hat to Ubuntu, go to the cloud, go to OpenStack in the data center, all without needing to be changed. But again, as we've realized over the 3 years, a single container typically does not a full application make. Applications are combinations of containers, and applications need networking and storage and security. And we would assert that we need, as a community, to maintain the promise of portability in multi-container, multi-host, networked, persistent applications, as we did with the single containers. And just this is a simple example of a format that Docker has, Docker Compose, but there's a lot of formats out there that are multi-container formats. This can be created on a developer's laptop, moved to the cloud with multiple containers, multiple hosts, moved back to the data center. Different networking stacks can go from a Cisco stack to a VMware stack, all without breaking the application portability. In order to make containerized apps accessible, to democratize them further, we need to maintain, we as a community need to maintain that promise to the next wave of adopters, to the next wave of users. And finally, third, there's a evolution, if you will, of how we work with each other and how we promulgate standards. Honestly, OCI and cloud native computing are good examples of this. OCI, Open Container Initiative, is a de facto standard of the Docker image format and the Docker runtime. And its purpose is to continue evolving that standard and to support its adoption. Whereas as we spoke earlier, Cloud Native Computing Foundation, higher in the stack, lots of innovation still going on, and its responsibility is instead to focus on reference stacks to help make the whole stack from metal to top of stack adoptable by organizations. Figuring out here within this room how we complement each other and work together, and then how we communicate that in very clear language to the market, because the market does not get this distinction today, is, I would say, a responsibility for all of us to help promote further democratization and not have the market get concerned and push back and say, well, we'll wait till you guys settle this out, because until you do, too much risk on us to adopt. None of us in the room benefit if that happens. All right, which brings us to today. I'm over time, so I'm going to be quick. Look, events like this are great for checking our tools and checking our gear together as a community. It's great for checking our maps, making sure we're going in the roughly same direction, heading toward the same objectives as an organization and community. And, of course, hallway track, helping each other out, tips, tricks, guidance on best practices, all so that we and our users and our customers and this entire industry can successfully get the benefits of this decade-long disruption. Because it's disruptive, it's a decade long. If we don't all work together, no one's going to get to the top. Thanks.
I guess I'm between you and break, so hopefully we can have an interesting conversation here. I wanted to share a really simple story with you guys today, which is to take a look at how the modern cloud stack is built and how we can actually work together better. I mean, we're here at the Linux Collaboration Summit, and I think part of our objective is to understand each other, to understand all the many projects that we're working on, and how we can do a better job working together to take this technology and innovation we're building and move it forward more successfully. My role in IBM is simple to describe and hard to execute. I own architecture for IBM's cloud platform. I lead the team that's designing and engineering our entire cloud stack, from infrastructure through applications and above. And what I want to do is kind of take you through what I think that cloud stack looks like and how we're building it, and areas where there are some challenges for us as a room to work on together. So let's get started. I'm going to break the cloud down into kind of 4 simple layers. And by cloud stack here, I really mean a full-fledged, full-feature cloud stack. I'm not talking about something just for cloud-native apps or just for traditional virtualization. We're talking about a world-leading public cloud platform that you can run all varieties of applications on. And if you look at that platform, it starts at the bottom with the infrastructure you actually run on. And one of the things that IBM fundamentally believes is that in cloud, there's more than one destination. That some people, many people, are going to run on a multi-tenant shared public cloud infrastructure, running in a data center provided by a provider like IBM or Microsoft or Amazon or Google or someone else. But there's also use cases where a dedicated installation makes more sense, where I want a provider to provide me that infrastructure, but I want to run isolated from everybody else. So I'm okay being outside the walls of my enterprise, but I'm not okay with sharing resources deeply with other users. And so there's a need for both public and dedicated off-premise infrastructure on which to run a cloud. There's also a need for what we call local, meaning I need cloud capabilities, but I need it inside a data center that I control as an enterprise. I need it inside my walls or inside an environment that I can control. So public, dedicated, and local are 3 delivery models, 3 infrastructures that cloud has to deliver on. And what a lot of people want is some consistency across those 3 environments. They want one set of APIs and one experience across those 3 delivery models. Now, on top of that physical infrastructure, you need a set of infrastructure services. You need support for virtual machines. You need support for networking, both core networking and networking services like load balancers and firewalls and packet inspection and DNS and CDNs. You need support for storage, whether that's block or object, archive or backup. All of those core infrastructure capabilities are really important to provide in a cloud environment. And even for people who are adopting a cloud-native microservices architecture where the platform they're building on isolates them from that infrastructure is still there, those services are still there, and they provide the fundamental underpinnings that support the platforms that ride above. Now, of course, a lot of us live in application space. We live in platform space, and what we need in the platform space, I think, is really two things. You need a set of core runtime models that support application development effectively with the speed and agility that we've heard this afternoon. That could be Docker container-based applications, that could be Cloud Foundry-based applications, that could be emerging models like a few weeks ago IBM announced an open source project called OpenWhisk for serverless event-oriented programming in the cloud. But you need this variety of runtime models, and then you need a set of foundational services to help you build those applications. No matter how you build your app, you need to figure out logging and monitoring and alerting. You need to figure out how to do delivery and update. You need to be able to figure out how to do security and how to deploy software. So there's a set of common capabilities, integration capabilities that exist for all applications that run on the cloud. And then finally, I think there's a set of domain-specific services that you expect to see. That could be cognitive or AI services, machine learning. That could be data. It could be analytics. It could be video, Internet of Things. These are services that you want to take advantage of in the cloud. They're in a particular domain or realm, but they're still important capabilities that you can build interesting and compelling applications on top. So as I think about the modern cloud stack that we're building at IBM, I'm thinking about this whole entire picture and how we bring that together and how we deliver that as a single coherent platform that users can adopt and build and run applications on top of. Now, as I hope is not a surprise to anyone here, IBM really believes in open. We believe in open source, we believe in open communities and open governance, and we have built our strategy for years, both in the cloud space and in the traditional software space, on top of a strategy whose underpinnings are based on open source. And the cloud space is no different, and there's an amazing amount of innovation happening in this room and outside this room in the cloud space. And so how does open source layer into that picture I showed? How do you build a modern cloud stack where all the layers within that stack are built on top of open source capability? So this is how we're building the stack. This is how that layering maps in our mind to open projects. At the base, we're using OpenStack, and OpenStack provides the compute, storage, and network resources that are needed both directly by users who are deploying applications and in support of the layers that ride above. At the platform layer, we have worked with containers, with Docker directly, and with the work that we're doing together in places like OCI and CNCF, Cloud Foundry, and OpenWhisk as an example of something that we've created that we want to do together with the community to start to have an open source model around serverless and event-oriented computing. In the foundational services space, there's a mix. There's actually a lot of activity around things like proxies and service discovery. There's a lot of great open source innovation in that space. But there's a lot of it, and there's a lot of different approaches for how you might solve those problems. In the logging space, we're using things like Elasticsearch, Kibana, and Logstash as the underpinnings for how we're doing things like logs and metrics within the cloud. If you go up into the application space, I mean, I'm from IBM, so I'm sure you guys know that we love Java, and we've done Java for many years. But we don't just do Java. We have a huge focus on things like Node.js. We've played a role in helping bring the Node.js community together and really supporting that community. A lot of new applications that we're building and that our clients are building are built on top of Node. And you have new things like Swift, right? Recently, Apple, with some help from us, have open source Swift. And we have started to build capabilities to run Swift on the server, to run Swift in cloud, to run Swift underneath Cloud Foundry and in Docker containers, and to help developers build web applications on top of Swift. So runtimes and open source runtimes play a really key role. And then up in those domain services, you have things like Spark. You have things like, in the data space, we have an offering called IBM Cloud that's really Apache CouchDB under the covers from an open source perspective. And you have things like the Open API Initiative and Swagger, helping to define how we all go build APIs and how we expose those APIs to each other. So I think the message here is that you can build a modern, capable, compelling cloud stack all based on open technologies. But there are challenges that go with this. And so what I want to do is spend a few minutes talking about some of the challenges. And I don't mean this in the spirit of we're doing anything wrong, but more in the spirit of how do we start to think together about that full picture and how all the different pieces we're working on might come together. I think there's two big challenges that I see as I try to bring that stack together for IBM and build a coherent experience. One is, no surprise to any of us, there's a ton of overlap between all of our projects. There's a ton of projects who started in a certain domain. They started looking at an infrastructure perspective of the world or a container perspective of the world. They've looked at the world from a certain lens, and then from that lens, they've expanded out. And so we've all solved networking in a different way, or we've solved storage in a different way. So there's lots of overlap. And in isolation, that's fine, right? But as you try to bring things together, that becomes more complicated. The other big challenge, I think, is how do you connect all these pieces together for a consistent experience? How do you actually build a cloud stack out of open technology that doesn't look like 65 projects that were glued together, that were never meant to actually work together? So let me dive into maybe 3 examples, specific examples of where we're trying to work through some of these challenges as a way to motivate the conversation. Take the networking landscape. Take specifically the container and infrastructure networking landscape. If you just look at, and these are not meant by any means to be exhaustive, but if you just look at some basics, within OpenStack, within the Docker community, within CNCF, within Cloud Foundry, everyone's trying to figure out how do we expose networking with an abstraction that makes sense for infrastructure applications that under the covers is pluggable to the physical network infrastructure and control plane that we want to use. In OpenStack, we have Neutron. In Docker, we have libnetwork. In CNCF, we have CNI. In Cloud Foundry, we have, I think, an active discussion. Some days it seems like it's CNI. Some days we're talking about how CNI maybe isn't quite do everything we need. Everyone has invented their own abstraction that's pluggable, which is great, but different, a different view of how you expose networks. So as an application developer, I have to kind of get my head around these different models, and I have to, in some cases, pick which model I'm going to use and leverage and exploit. We ran an experiment as we were building out our container services, looking at how do we actually just connect all these things together. So we built a stack that looks like this. I have Kubernetes talking through CNI to libnetwork and Docker, talking through the Courier project to Neutron, down to OVN and OVS. The good news is it works. The bad news is I feel really bad for the ops team that's going to have to run all this stuff and figure out what the heck went wrong when a container came up and can't talk to anybody or the network goes away. So there's a complex stack of abstractions that are coming together within this space. Second example, container orchestration, right? There's not enough room on the chart to talk about all the different flavors of container orchestration that are brewing right now. We have work with Swarm, we have work with Kubernetes and CNCF, we have Magnum and OpenStack, we have Diego and Cloud Foundry, we have Mesos and Marathon. All of them solving the container orchestration problem with their own perspective, with different strengths and weaknesses. And again, it's not a statement that one is better than the other. We should pick one. I'm a pretty pragmatic guy. I don't think we wind up picking one in a lot of cases. But this is the landscape that people have to work through. As I've been trying to figure out how we build container service and multi-tenant shared container service on cloud, I want a service right now that exposes things like the Docker Swarm API and the Kubernetes API so those communities of developers can naturally interact with that service. But that means I got to figure out how to bring these things together, and they have to share resources, and they have to have a common view of networking, and they have to sit on top of the infrastructure that I have. And they have to connect out to other services that exist within the cloud in a consistent way. Third example, authorization. Here I'm specifically thinking about things like within all of these platforms, you have a core problem you're trying to solve. But what you quickly find is that you have to have some representation of users and groups and authorization policies and groups of resources, and you have to be able to specify rules on those groups of resources. And many of these projects have invented their own notions. Cloud Foundry has orgs and spaces. And in organizations and spaces, I can group users and I can define who can do what. In OpenStack, you have projects and subprojects. And again, in isolation, those things are fine, but you bring them together, and now I have a cloud stack that has projects and subprojects and orgs and spaces and who knows whatever else comes along, and it becomes very hard to give the user a consistent experience for how they specify who can access what resources that they're running in cloud. So these are just 3 examples of where these different projects that we're bringing together in the stack have some overlapping or connecting problems that we have to work through. Now, what are we doing to try to figure this out? We've been running running some experiments, and I thought I'd just share 2 experiments with you where I see some interesting potential, and maybe some areas that we can talk further and go collaborate together. One is around the networking problem I illustrated, or the container orchestration problem I explained. One of the common things we all need in the container space is some notion of a container group. And by group, I mean a collection of container instances that are running the same image that you're load balancing across and that you are using for failure recovery purposes. And today, we have this interesting situation where within a platform like Kubernetes, there is this notion. There's a notion of replication controllers. Within Docker Swarm today, there isn't this notion. You know, I have something close to it with Compose, but I don't really have any formal notion of a collection of containers that I want to be size 5, that I want to auto-scale and recover as things fail. And so we did an experiment where we said, can we take the replication controller implementation from Kubernetes, which implements this group notion, and apply it against containers that are managed in Swarm. So I can actually reuse that implementation across both of those communities. Right? Is that the right way to do it? I don't know. It's an interesting experiment. But I think it proves the point that we could collaborate together and we could solve some of these common problems together instead of inventing different implementations always to solve similar problems. Let me give you a second example. So look at Cloud Foundry. Cloud Foundry platform does a lot of things. One of the things that Cloud Foundry does, which I think is really good, is services. It has a very good notion, formal notion of services. I am a firm believer that cloud platforms will be a mix of applications that you run and services that you use. Right? Not everything will be in VMs. Not everything will be a container. Sometimes you will just use a service provided and run by something else. And I think you need a formal notion of service. How do I find them? How do I connect to them? How do I disconnect from them? How do I provision them? Cloud Foundry's invented a model for that. It's a good model. The container world doesn't really have that model formalized today. So one of the things that we did is we connected the Cloud Foundry service binding and brokerage model to our Docker container service, so I can deploy containers and have them connect to services. And that can happen through the same interfaces, and it can happen through the same catalog, and it can get exposed to applications in the same way. So as an application developer, I know what the notion of service binding is, and I know how to go find my information. And regardless of whether I pick to write that app and deploy it with CF Push, or whether I decided to write and deploy that application with Docker Run, I have the same notion for services. So it's a second example of where I think we could collaborate together to solve these problems. So my core message to you is really simple. The modern cloud stack is broad. It encompasses many of the projects we're all working on together. I think the end state is going to be that these projects get brought together into a coherent platform. And I think we have an opportunity to work together to build that modern stack, to make it be based on open technology, and to make sure on those edges and overlaps and boundaries, we're collaborating to have the best answer possible to bring that stack together for our users. Thank you. Sure.
So have you been talking to Dave Ward from Cisco? I don't know if you took on his talk.
No, I did not.
It's funny, we have 2 CTOs come up, and it's a similar thematic here, which is, you know, we have a mix of different components. Many are often overlapping. We're not quite sure which abstraction layer or which networking components we want to use, but we need to somehow come together.
Yeah.
You know, that's what we really want at this event. You know, the OpenStack board is meeting downstairs right now. We've got Apache projects who are meeting here. We've got a bunch of projects coming around. So I hope we can continue, and I hope you can participate in that discussion. I think some of the examples you gave were great to, you know, how these things will shake out over time. So,
yeah, absolutely. Love to.
Great talk.
Great. Thank you.
Thanks for coming.
Push really hard.
Yeah, sorry.
Right. Okay, thanks very much, everyone, and thanks, Jim, and thanks to the Linux Foundation for this opportunity. As Jim pointed out, we just wanted to talk a little bit about what we're trying to do at the moment with a series of new tools that we've been developing. They're actually based on work we've been doing for about 15 years, but we're actually trying to create a new generation that can take advantage of all of the new technologies that we've been hearing about today. And from our side, this is really important because what we're looking for is advice and collaboration and all of those sorts of things to help us drive these new systems forward. I should also note that while this is being led by the Clinton Foundation, it's also being generously supported by the Government of Australia, also the government of Kenya and the government of Canada. So there's a good degree of collaboration going on there. I think the interesting thing that you'll find in this chat is we don't have too much private sector at the moment. It's very focused on government. And that's a really difficult challenge for us in many spaces because governments are generally a little more wary of new technology than maybe the private sector is. So I wanted to start out making a fairly clear point. Climate change is a huge problem. The issue we have is that it crosses everything. It affects our natural systems, our human systems, infrastructure, financial systems, and the interactions between the two. So agriculture is a very good example of that. We all need to eat. Massive amounts of climate change change the dynamic in the landscape, how and when we can produce food and where. It's also a huge problem to address, again, because it's global. So everyone is contributing to climate change, but everyone is contributing different amounts. And everyone is affected by climate change, but everyone is affected by different amounts. And so you have this very difficult dynamic that's going on around the world, and I'm sure you've probably seen that in the news clips around climate change and negotiations and things like that. As Jim alluded to, probably one of the biggest steps forward globally in the last 20 years through the United Nations Framework Convention on Climate Change. And I highly recommend, having heard all the acronyms here, that if anyone wants to step into a new world of acronyms, climate change is a fantastic place to start. It's a pretty significant agreement because it's the first time that all the countries have come together and actually worked as a group rather than splitting from a developing standpoint. The key points are all countries agreed to try to keep temperature increases below 2 degrees. Now that is very challenging. In fact, some science would suggest that we've already crossed that mark. But to try to do that, assuming the mean, means we have to start cutting emissions massively now, and we actually have to start having net zero emissions by the middle of the century. And that's very different to the current trajectory that we're on. But one of the outcomes that was really positive is 87 countries submitted plans for how they plan to try to reduce their emissions to hit these targets. Now, they're still just plans. They need to be implemented, but that's the first time this has happened. One of the other key aspects that's come up is a sudden push on the need for transparency and accountability. One of the big problems is, in many developing countries in particular, how much emissions are actually being produced. Because it's not a simple thing to estimate all the time, especially in the land sector. And that means that it's not always easy to detect what are we actually mitigating against. And these countries also have considerably bigger short-term problems than climate change. So if you say you want a system for addressing poverty, they're more likely to take that over a system for estimating emissions. So the Paris Agreement really focused on trying to get those things in place. And really importantly, there was this push to actually start getting more climate finance available for developing countries, with the plan of $100 billion per year by 2020, every single year, to try to drive both mitigation, reduction of emissions, and adaptation. One thing that most people who don't work in the space a lot don't realise is that land use is actually a huge part of the problem. It's currently 24% of global emissions, mainly driven from deforestation and agricultural practices. More importantly though, in many developing countries it's far more than 70% of their total emissions, and in some cases in Africa you can find it's above 90%. So if those countries want to do anything about emissions, the land sector is where it's at. For many of our developing countries, the US, Australia, it's more about coal-fired power stations, but in these countries it's more about land use. One of the key things though is these emissions are also caused by poor land management. So a lot of these emissions are being driven not only just because they're deforesting, but then also ongoing poor land management that continues those emissions into the future. The key point is that land has to be part of the solution. So as I mentioned earlier, we wanted to hit net zero emissions. The only way to do that is to turn the land back into a sink rather than a source. The sink potential is huge, 14 gigatons of CO2 a year. That's roughly 2.5 times the total US emissions. So proper policies and thought can actually do a lot, but that is still only a potential. There's still a lot of work to do that. Improving land management will obviously help reduce emissions, but as I pointed out earlier, most of these countries, especially in the developing world, have far bigger problems on their plate. And so what we need are systems that not just do emissions, but also really help them with other issues of food security, agriculture, land use planning. And so it's trying to make sure that a system actually meets all of these criteria, because otherwise a government is very unlikely to keep running it in these countries. All of the action that we need these countries to take in the developing world requires some form of support. The climate finance story comes into this very clearly. To actually access that, though, we actually have to know how much is being reduced, because a lot of these things will be looking at actions that are being taken and the countries will be paid for those actions. So to unlock the potential of that climate finance needs movement on the measurement capabilities. The other key point that we often miss is that countries themselves need to drive the system design. So too often we drive global designs down into countries